So one of the things you want to look for with developing a good healthy soil is having a good diverse range of perennial plants that will act as a shelter to cover the soil and help release exudates into the soil that are going to feed the microorganisms in the soil. And ideally, if you can feed that soil some organic matter, it's going to supplement the sugars that are produced by the plants as a food source for the microorganisms. So we're going to jump in here and grab a sample of soil, and we'll bring that back to the laboratory and have a look at it under the microscope and see what's going on. Okay, so once you've got your dropper, you can put a couple of them on your slide here. So about 3 drops should do the trick. And that's going to be your representative sample from your site. And you should probably do this about 5 times for a particular site. And it's going to vary in different locations, but for any particular location, if you get 5 samples and make a slide for us and just check what kind of life you see in your soil, it just gives you an indication about the life of that soil and how healthy it is, and what kind of microorganisms are in there. So once you've got your sample there, you lower the cover slip on. So the way to do that is to lower one edge of it, just holding the cover slip by the sides, and then just gently lower it down from that, and that will stop any air bubbles forming in your preparation. Then you take your slide and you put it on the stage of the microscope, which is under these clips here, and that just positions the slide under where your lens of the microscope will be able to focus in on it. So once it's located under your lens, you then turn your light source on, which is the button down here in this case. So turn it on. So that's the light source on. So the easiest way I find to locate the specimens is to use the 10 times magnifying glass first, objective lens is what it's called, and you multiply the 10 times by the 10 times eyepiece, and that gives you a total magnification of 100 times. So what I do is I use this coarse focus knob here to locate the specimen under it, and then once I've got it, I flick across to the 40 times objective lens. So when you go 40 times 10, that's 400 times, and that gives you a good magnification to be able to see some of the bigger bacteria and fungi, hyphae, and nematodes that are in your soil sample. So I'll give you, it takes a bit of trial and error to find some good samples, so I'll put through some footage of some of the examples of the nematodes and fungi and bacteria in a moment. But what you're trying to really do is, for these samples, get a fair representation of those amongst your 5 different samples. So if you're getting a few, maybe 100 odd bacteria cells and 10 odd strands of hyphae in that 3 drop sample, and a couple of beneficial predatory nematodes, that would be a good indication of the soil health. But if you're putting a sample there and all you're seeing is the sediments of the soil and there's very little evidence of any life in it, then that indicates that that site would benefit from an addition of a compost tea that's been inoculated with some bacteria to help bring the life of that soil up again. Other things you can do other than just create preparations is feed the soil life by getting good healthy plant growth, and the good healthy plant growth will also provide a food source for those microorganisms and help them get going. You can see in these aggregates here how they're full of all these roots, and these roots are the part of the plant which is sending out the exudates into the soil that are going to feed the microorganisms. And with those exudates that they put into it, which is sugars, but as the plant gets healthier, fats and proteins as well, it's attracting in the soil around the base of the plant all of the beneficial microbes that it wants in that soil. So it's deliberately creating an environment in that soil that will put the microorganisms in that soil that are most beneficial to that plant. So it's bioengineering its own environment for its own benefit, which is quite clever. And as those beneficial microorganisms colonize the soil site, they're going to outcompete any of the pathogenic or less favorable microorganisms that can cause the plant damage. I'll get into all that in a sec.